So next, we will have the first presentation given by Professor Nizar Habash. It's my pleasure to introduce you first, Professor Habash. Dr. Nizar Habash is a professor and program head of computer science at NYU Abu Dhabi. He is also the director of computational approaches to modeling language lab. Professor Habash specializes in natural language processing, computational linguistics. Before joining NYU Abu Dhabi in 2014, he was a research scientist at Columbia University's Center for Computational Learning Systems. He received his PhD in computer science from University of Maryland, College Park in 2003. He has 2 bachelor degrees, one in computer engineering and one in linguistics and languages. His research includes extensive work on machine translation, morphology analysis, and computational modeling of Arabic and its dialects. Professor Habash has been a principal investigator or co-investigator on over 25 research grants, and he has over 200 publications, including a book entitled Introduction to Arabic Language Processing. So let's welcome Professor Habash to give us the first keynote talk.
Thank you, Cheng Lang. Do you hear me okay?
Yes.
Excellent. Well, thank you also to KAUST for hosting this event, and thank you to Dean Omar and to all of the people who helped in putting this wonderful webinar, series today together. I hope the slides are shared, the screen is shared okay, and you see my title, right? If there's any problem, just let me know. So I'm honored to be giving the first talk in the webinar, which we decided that it would be appropriate to be a short introduction to natural language processing. And my guess is that a lot of people coming into this may actually have different degrees of background in natural language processing. So I tried to make it set up in a way that would actually be more also kind of a soft introduction to NLP in general as we talk about Arabic. But before I get into this, I want to just say a couple of things about my university. So I am at New York University, Abu Dhabi, which sounds kind of weird having 2 city names in the name of university. We're part of a global network of 14 different campuses that originally started with New York and has many places all over the world. And we have a beautiful campus in Saadiyat Island in the city of Abu Dhabi. It's a liberal arts college with an integrated science college focus on research. We have students from all over the world in it. So if you know people who are interested, smart people interested in liberal arts education with strong research, recommend our university to them. Specifically, I work in the lab called Camel lab, or the computational approaches to modeling language lab. And our focus, as Xiang Lang had said, is on Arabic language modeling primarily. Within the lab itself, we've had about 80 papers since in the last 6 years that we've existed, and about 20 different resources. Our focus has become, in the past I worked on Arabic, but I worked on many other languages also, and my focus in the last few years have been totally directed on Arabic language processing. So I'm very happy that this event by WTI and KAUST to support an important application in NLP for Arabic is happening. and you can see the link to our site is through the university or camellab.com. So I lead a large team. We have about 17 people with us working this semester. And this is the team that is involved in particularly the toolkit that I will also talk about as part of my presentation today. So the plan for today, I thought I would start by talking about natural language processing in general, just to kind of situate what is this about. And then we'll talk about Arabic language processing challenges. And then we'll talk about solutions from the Camel Lab. My slides are designed so that they can be bilingual. So if somebody I know there's a lot of people in the Arab world who are interested in this area, and I thought this would be a good educational kind of resource for them to see both the Arabic and the English. But I will be doing this presentation only in English for now, and Arabic examples as needed. So let's start. So natural language processing is a type of artificial intelligence research. So sometimes you find it called computational linguistics or language technologies, human language technologies. And you can tell from all of these different icons I have, it's pretty much a huge part of our life today, from talking to Siri, to spell checking with Grammarly, to complaining about the sort order of posts and tweets that Facebook or Twitter respectively are doing, to sentiment analysis, OCR, all of the, and search, of course, and machine translation. So all of these are basically successes, really, of the area of natural language processing, which has been one of the earliest efforts within computer science was actually in language-related things, from the cryptography of language to machine translation, particularly, as you can imagine, for all kind of political reasons. Natural language processing is a field that is quite multidisciplinary. It has people who come to it from computer science, some come from linguistics. I come from both, in fact, as I was introduced as, but also people come to it from cognitive science and psychology. We actually have a lot of people who make the transition into this field from other areas and acquire the needed knowledge to do the needed machine learning to kind of help them with it so that they can do interesting work and just make interesting discoveries. And it's strongly connected now to a lot of other areas of research like data science and computational social science, digital humanities, where NLP is basically a support backend mechanism that help people working in those areas to work on a much larger scale than they could have done basically through manual, careful reading and analysis. Now, I want to make a distinction here in terminology between what we call applications and enabling technologies, where I think of applications at all of the examples that I talked about earlier, where there's a user on one end who treats the NLP process as a black box. They don't really care. They have an input, let's say a French or Chinese sentence, and the output is Arabic or English. Very clearly well-defined black box kind of with a particular user. On the other side, there are things that we call enabling technologies, which are huge areas of research, in fact, in the field of natural language processing. And they're about kind of low-level components that we put together so that we can do interesting things for the applications. I'll just give an example here to kind of also motivate what I'll be talking about later with Arabic. Something called tokenization, which is basically about taking the text and chopping it into smaller pieces. There are lots and lots of techniques for doing this. There are techniques like word pieces and BPE that are used in machine learning that tend to be language independent, and there are techniques that are more language specific that are aware of the grammar and linguistics of the particular language. Just to use an example here, this is a single word in Arabic, وَسَيَكْتُبُونَهَا, and it means "and they will write it." So it translates into almost a whole sentence, 5 words in English. So the intuition of why we want to do a form of tokenization is because a machine in machine learning may see this single word and have never actually seen it in its training data. You see it in the test, but not in the training. But it's possible that it saw different components of it in the training. And so the idea is to try to create a different way of defining the tokens to help the machine learning in the process so that it would not just see a word, say, oh, I don't know what this word is. I'm going to just make a good guess or drop it, for example. And tokenization in this example is done so that it would be closer to the kind of to create a harmonious alignment with the English, with the intuition that it would improve the ability of the machine learning components to learn how to translate better. So tokenization, morphological analysis, tagging, are some of the examples of things that I'll be talking about later, but I just wanted you to kind of get a sense of why we talk about them. So they're not an application in themselves, but they are enabling technology to other applications. Now, of course, the series is in the webinar focuses on machine learning, and just want to kind of do a little shout out to the older traditional methods, what are called rule-based approaches, just to kind of give you a sense of the range of things that are available. So rule-based approaches depend on linguists usually thinking of particular rules of the language and how to utilize these rules. That could be also in the form of developing lexicons or specific resources where you ask people to give you specific information that you can then use within your full black box application system. And machine learning approaches, of course, take the view that we're going to discover such rules, let's call them, from the training data. And there are lots of different techniques. The most popular today, of course, is deep learning techniques that are just had a fantastic rise in success in the last couple of years. But there are also other kind of techniques that are statistical. And all of these techniques come with some pros and some cons that sometimes actually is tied basically to a basic fact that they need data, and if you don't have enough data, you may not be able to actually make use of certain techniques, or it wouldn't do as well. Machine learning, of course, approaches are the dominant approaches these days, but you can always find clever ways of integrating existing ideas, features that are based on older techniques like rule-based or statistical techniques that can be used as features as part of the work that you're doing, particularly, as I said, if you're facing issues with the size of data that is available to you. And I know there's a competition coming, so keep your mind open to possibilities of things that you can use and how you can use them to be able to win this competition. So when we talk about machine learning, of course, what do we need to give machines? We need to give them examples. Here I'm focusing obviously on approaches that are, in the examples I'm using, on approaches that are annotated examples that are used for what's called supervised machine learning, as opposed to unsupervised machine learning, where you can actually learn a lot, in fact, just from examples of text. Simply the fact that words occur with other words more likely than with different kinds of words, it tells you a lot about those words. So you can think of it as almost a latent annotation that exists in the so-called unsupervised methods. But when we talk about supervised machine learning, we typically think of an input and an output, and then we're giving those examples to the machine at a very, very high abstract level. And so when you're translating, you give language 1 and language 2, Arabic and Chinese, learn how to translate between the two, right? Sentiment analysis, as the competition is on that, would be here's examples of tweets, let's say, and here is the labels that go with them, whether it's positive, negative, or neutral, and then the machine would learn from this. So what's important to keep in mind, I hit on it earlier, size of training data is very important. The domain and the genre, so this is the kind of data that you have. You can imagine if you have lots of data that is in a particular kind of genre, like the news or the United Nations resolutions type text, when you go to translate poetry, you're not necessarily going to do much better, right? I mean, you can do a lot better if you have more examples of the thing that you're interested in working with. Also, the quality of the annotation is extremely important, and that's where if you have garbage in, you're going to get garbage out, and that's why it's important when competitions of the sort that we're having today, and also there's many competitions that were run in the field, excuse me, in the Arabic natural language processing workshop, for example. The importance of the quality of the annotation cannot be underestimated, because that's kind of the thing that we trust for the learning and also for the evaluation. Now, I like to compare also to kind of get your intuitions kind of heightened here between machine learning and human learning. So babies learn language quite fast, like within the first 2 years. At the beginning they don't talk, and then they can't stop them from talking. But the difference between humans and machines is that the dominant theory in linguistics today is that humans are predisposed to acquiring language, that we have basically a basic sense for how to acquire the language, what's called a universal grammar that's built in, that we acquire through evolution. There's lots of views on how that came to be. But this kind of independence, you can think of it almost from a machine learning point of view. When you talk about an actual machine, that is not necessarily there, right? So how do we actually model that? We model it through having algorithms. We have resources that are collected, like word embeddings, etc., that can create additional information that can actually help us with the modeling. So the work on algorithms is still extremely important, as much as I mentioned the importance of the data itself. And keeping combinations of all of the tools that are available to you as you approach this competition, from older techniques, resources that exist. Try it. It may help you. In fact, particularly as you look at the amounts of data that's available to you for doing the task. And this field, just to kind of regarding machine learning, the field is impressive. It's in continuous growth. We're having a couple of revolutions, at least during the last 20 years, that have been active in the field. But also, it should be pointed out to all of particularly younger people to become aware. There's more talk today about what's called green AI versus red AI. So, some of the techniques that are used can be quite intensive in the way of, they're using the machinery, have a very big carbon footprint. And there is a sense also of trying to balance, how do we create very smart tools that are also not necessarily destructive of the environment or not bad, not even talking here about issues related to bias. That we should also be very careful about, particularly as you approach a topic like sentiment analysis. This is something perhaps of a meta discussion about what is this going to be used for, so you keep the bigger picture in your mind as you actually are focusing on the particular application that you're doing. And then as you do this, always, just perfection is always going to be elusive. So, keep trying different ideas, and trust that even like we talked about, I think the top 3 winners are going to get rewards, but everybody else will be a winner in some way. I know it sounds like a cliche, but also systems that are not necessarily in the top may actually be excellent in other dimensions, like in terms of their environmental footprint, or in terms of the speed that they run in, etc. So just keeping that as part of a bigger picture of when we talk about NLP and machine learning in general. So now I'm going to talk about Arabic NLP challenges. And having been in this community for such a long time, I am aware that there are lots of people working on Arabic NLP who do not necessarily speak Arabic. So I'm going to try to explain this as much as possible so that it reaches as big of an audience as possible. So typical problems that we talk about, and I'm going to go through all of these, are what's called orthographic ambiguity, which is how things are spelled, morphological richness, how the words are formed, dialectal variations, differences between different groups of people who are supposedly part of one language, and then orthographic inconsistency, or you can call it spelling errors if you want, but it's actually more complex than that, in addition to typical things like resource poverty. So Arabic script, if you know nothing about it, you should know that it's written from right to left, so important. The letters are actually written connected, and they change shape. So the word at the top is a 7-letter word, al-Arabiyya, which is the name of the Arabic language, Arabic, effectively. And these are the different letters that are basically making up this word. And in fact, you can see the coloring here is intended to show you how the reduction in the shape, almost like it gets its size by half when you connect everything. It's always written that way. That's the standard way of writing it. And as you work with different environments, say you're programming, sometimes you'll be frustrated that you will, particularly if you're an Arabic speaker, actually, you'll be frustrated because some interfaces do not actually print the Arabic properly. That's not a problem in Arabic, that's a problem with the interface itself in this case. And in some cases, the letters will actually appear from left to right instead of right to left, which also is problematic. So I would recommend for the programmers, as you're working with the data, to do the sanity checks of put it in an array, check what is actually the first and second and third to last in the array that you're looking at, just to confirm that nothing is actually messed up in the way you're approaching the algorithm. In computer science, basically, we don't care really that Arabic is written from right to left or left to right. In memory, everything is ordered from first to last. So the first letter in the Arabic word, the first word in the Arabic sentence, is going to be also the first in the array that you usually be working with. Okay, and then Arabic also should just point out is actually not, the Arabic script is not just used to write the Arabic language. So script versus language, it's used to write many languages, just like the Latin or Roman script is used to write many European languages that are different. The color green here in the little bubble or the egg on the side, the green letters are the letters that are used in the Arabic language, the standard Arabic text. And the others are many more, in fact, are used in other languages like Persian and Kurdish and Urdu and Pashto and others. So orthographic ambiguity is, orthography is about writing or spelling, let's call it this way. And because Arabic script uses what's called diacritical marks, so these are little squiggles that we put over and under the letters. You can see the word at the bottom of my slide. I cannot technically pronounce the word at the top without actually telling you which of the different forms of the word I mean. To specify the different forms of the word, we put these little markers, what's called diacritics. And now Arabs typically get introduced to this as children, and also they're used in holy text in the Quran to basically make sure that people do not mispronounce things in a way that is not intended. But in most written Arabic texts, it's almost never seen. It's less, it's almost 1 to 2% of all the words in the newspapers, for example, have some diacritics, not even all of the diacritics. And it's because Arabic speakers, proficient Arabic speakers, are able to disambiguate the text completely using the context of the different words that are available in it. This could be a whole other lecture about why does this happen better in Arabic compared to potentially with other languages, what are the features. I'm happy to, if you have questions about it later. But as a result of this, standard Arabic has about almost 7 different spellings, diacritizations, like the same basic spelling of the letters, but different diacritical marks. And they have about 3 different core meanings or lemmas associated with them. In this example, for instance, the 4 words actually, when you just change the diacritics on them, you get things like, and with our contract, with our necklace, with our psychoses, and he stresses us out. And this would be actually a dialectal version in that case. So this probably is one of the biggest problems that we would face when we are working with Arabic, is just the ambiguity that a word, in fact, there are some examples of work on sentiment analysis showing the same word being interpreted as negative or possibly neutral or positive, depending on which diacritization you get. Now, the second aspect is morphological richness. And morphological richness is about, when we say morphology, we're talking about the structure of the word, what goes inside a particular word. So let's give you an English example. If you say, cars with an S at the end, the S tells you that it's a plural. It's more than one single car, right? And that would be the morphology of that word. In Arabic, the morphological system is described as quite rich. The verb in Arabic could have up to 5,400 different forms. I put some examples of these, and these are all different forms connected to the word to say, so قال قالت قال قالوا قلت وسنقولها, which I analyze on the left side, has all the different components that go in the form of writing the word. 5,400 is a lot, and it's because also all of the direct objects of the verb are actually, if there are pronouns, they're written attached to the verb. Now compare this to English, which has 6, and compare that to Chinese, which has 1. Right, so it's almost, Arabic to English is almost 900 times the amount of richness that you would have for these different forms. So that is obviously, from a machine learning point of view, adds complexity, where you have a lot of forms that, unless you prepare them, tokenize them, or pre-process the text in a smart way, you will have trouble, because your vocabulary becomes in the millions as a result, which would be problematic, as you can imagine. So the third issue I wanted to bring up is what's called dialectal variation. And in Arabic, often is thought of as, it's one language. Some people would call it a single language family. There are forms of the language that are all kind of being used on a daily basis together. So classical Arabic, or it's the language of the Quran, on historical text. And then there is modern standard Arabic, which is the official language, and it has standard grammar and writing, spelling rules, and it's considered the national language of all the Arab countries that are members of the Arab League. It's also an official language in other countries too. And then we have the dialectal Arabic, which is actually the predominant form of the language that is spoken. This is what people speak on day-to-day at home. They don't speak in the standard language, which is extremely quite different actually from the dialectal forms. And the dialects have no official standards, but obviously they have grammar in the linguistic sense, because otherwise you cannot have a language without grammar, because then you cannot have any understanding of communication between, a language is basically a contract of understanding between me and you. We say certain things and you understand what it means. And maybe things change over time slowly, so there is a grammar in that sense, but a grammar in the sense of grammar books that are taught to children in the Arab world, that doesn't exist. There are grammar books for the dialects written in English for people learning Arabic dialects as a second language. And it's often thought of as the mother tongue, as opposed to the national tongue. In the past, the common sense view on Arabic dialects was that dialects are really do not necessarily need to be studied too much because they're only spoken. You don't see them written, there's no records of them. And in fact, we're finding that that is actually becoming less and less true, that there's a lot of data on social media, on Twitter, that is actually almost completely dialectal. There are also people writing novels. One of the data sets that we developed, we've collected in my lab has about 100 million words of novels written in Saudi Arabia and other Gulf. 60% of it came from Saudi Arabia, actually, of novels written in Gulf Arabic. Right, so it's becoming kind of its own living form. And as I kind of said, all three of these coexist. So this is not like talking about Old English, which is pretty much a dead language. Quranic Arabic is alive, so a Muslim Arab person would pray in the Quranic Arabic, watch and read the news in standard Arabic, and then talk to his family in the dialect. And all of these basically coexist together. The dialects can be quite different. So this is a beautiful map that kind of overlays through color the dialectal areas over the political boundaries of the different Arab countries. And you can say in Saudi Arabia, the host country for this event, there are three different areas at least that can be distinguished between the Gulf, Hijazi, and Najdi, that can be quite different from each other in certain ways. But the general grouping classification that you would find in tools that are available would be that, collectively there's the Gulf or Arabian Peninsula Arabic, Levantine Arabic, which is kind of more north where Palestine, Jordan, Syria, Lebanon is, Egyptian, and then the Maghreb, which is the western part of the Arab world. You'll find, in fact, that there is also multiple dialects even within the same country and within different socioeconomic levels. And in fact, this is an area that has been under a lot of study, dialect identification. There was a competition this year called Nuanced Arabic Dialect Identification that had, I believe, about 100 different labels. I was part of that. I was also part of a previous competition that looked at 25 cities in the Arab world. So people are getting into quite nuanced distinctions of looking at this. And this may be relevant for the task that you're looking at, where dialects and could be another feature basically that you can look at as you're trying to figure out the sentiment for sentiment analysis. So I'll just give some examples of the differences that we actually see in the dialects. Some are purely phonological, and these are the ones that are immediately seen. So for example, in standard Arabic, there's a sound qaf that gets pronounced in multiple different ways depending on the dialect you're in. I'll give you an example. So at the bottom, the word qalb, it means heart, as in the heart, right? And it could be pronounced qalb or galb or elb, depending on which dialect you belong to. There's also cases where the same pronunciation, like the word fajr, could actually be, could mean poverty, or it could mean dawn, as the time when the sun rises, depending on the dialect that you're in. So that could actually be, I mean, there's an interesting example where, suppose poverty could be seen as a negative sentiment associated term with fajr or fajr. So I'm telling you almost what my dialect would do, maybe slightly positive if it's used in a poetic way, so that those would be examples where the difference in the pronunciation may or may not necessarily show when the spelling is done because of the lack of the standards for the orthography. Morphology, I talked a lot about earlier about how complex morphology can be for Arabic. The dialects have in some aspect some simplification. Like for example, the standard Arabic has what's called case. So like Latin, for example, has different forms of the noun that tell you whether this noun is the doer or the doee or for that person related to a verb. Arabic has some similar distinction in the standard Arabic, but not in the dialect. In dialect, pretty much this aspect has gone. So that's a simplification, in fact. But then there are other aspects where we have what's called clitics. So clitics are basically, you can think of them as little contractions. They're really separate words that are just always get mushed together. A classic English would be like, can and not becomes can't. Will and not becomes won't. But in Arabic, it happens systematically for all the verbs, let's say, in the language, not just for a few of them. So at the bottom, there's an example of a verb in Egyptian, وَمَا كَتَبْتُ هَلُوش, and it means, and you all did not write it for him. It's one single word. Even the standard Arabic has to write it in 3 separate words. And I suspect, with data that is available from social media, such things would actually be found. Now, some of the differences also happen not just by kind of the complexity, but also the form. So for instance, the future marker varies. It's a particle that gets attached to the verb in one of its forms, and it would have different forms. So sayaktub, hayaktub, hayaktub, ghayaktub are basically still saying the same thing, but there are actually different particles. Some of these particles can be tricky, by the way, because they can be ambiguous with a letter in the word itself if you give it a different dicritization and a different interpretation, different reading. So it kind of gets complicated. And then we have just pure lexical differences. So the lexicon, the language itself is different. So, I've always kind of amused when English speakers talk about how British and American English are different with tomato and tomato, where in fact we have, half a dozen, more than half a dozen of different forms in Arabic, actually, like tomatish, tomatish, matisha, uta, bandura, bandura, tamat, tamata, tamata, and guta, among the different forms that exist. And then also you get words where it's one single word, like this word barad, which could actually mean either a fridge or a kettle. So something to do with heat and something to do with coldness, depending on the dialect that you're in. If you kind of go and search for it online, you will find the most famous barad is actually Brad Pitt, which is kind of ironic in some ways, because his last name is ambiguous with the word house. So looking for a fridge for the house, you get Mr. Brad Pitt, the actor. Last part is about the degree of spelling errors and consistency. So because standard Arabic is not the kind of the mother tongue directly of all Arabs pretty much, and they have to learn it in school, we find that there is some degree of errors that can reach up to 30% of spelled text when it's not edited carefully. So when people write tweets particularly, you would find these kind of errors. So in this example, I underlined examples that would be considered suboptimal spellings or spelling errors in the standard language. So that's something to also keep in mind. The typical solution, by the way, is you either have to fix the error or you have to basically normalize the error. So some of these so-called errors, like the spelling of hamzas, which I'll mention a bit later, we just kind of remove them from the whole text and we just pretend that we just ignore them effectively. Different approaches, that depends on the task. It may help or not help, but it will be something to consider for you guys as you work on this. But also in the dialect, because of the lack of the standard orthography or official orthography, we find a lot of different spellings. So this was from a paper we had where there was 27 different spellings of a particular word in Egyptian Arabic. Maybe ul-hash, these are the examples with the counts according to Google at the time when we did them. So you can see some elements of the word that look similar, but then the task becomes about how do I make sure that all of these forms somehow are clustered together when I learn my classification from them. And finally, and I'm not really sure actually if the data in the ESSA data set will have this, but there's also another phenomenon called Arabizi, which is basically Arabic written in Roman script. So I put some examples at the bottom where some digits, like a digit for 2 or 3 or 9, are used actually as letters. And you will find this also quite often in social media. Okay, so these are kind of like all the kind of problems that we will have to deal with when we are coming to working with Arabic text today, particularly text that comes from social media. Now I'm going to use the remainder of my time to talk to you about some of the solutions from Camel Lab that address some of these. I cannot commit to saying that it's all of them, but many of them. And just to kind of give you a bit of sense to kind of go and explore on your own, the Camel Lab website, if you do the www.camel-lab.com, you find the lab with demos for a lot of the tools that we are working on. You can find linking to the resources that we have. And all the resources here, I would say all, the vast majority of the resources are available for research for free. You just have to register just so that we can basically have an accounting of how many people are registered. In some cases, we don't need it. In some cases, we need it. And this is for reporting purposes so that we can keep funding coming to the lab from the university to show that we're actually doing a good service and people are making use of this. So this would be one way of rewarding us, aside of when you use our tools to, of course, cite us as academics. That's basically the main currency that we have. So this link, I will share all my slides also with Xian Yang, so she can share them if that's a possibility with everybody else. So don't stress about copying things now if you couldn't do it. So just examples of the different resources, which include corpora, lexicons, specific tools, but also guidelines. So this issue that I mentioned, for example, earlier about not having standards of spelling, for people who are working, for the dialects, for people who are working on things related to text generation in the dialectal space or translation, this becomes a bit of a problem. Speech recognition, for example, the dialect, this becomes a problem. And one of the things that we've worked on in the lab, and this is work that started at Columbia before I joined NYU Abu Dhabi, was to come up with guidelines that actually help us define how to actually annotate the data so we avoid this garbage in, garbage out that happens from the annotation. So that also is within the full realm of the resources that we develop in Camel. I'll specifically talk about Camel Tools, which is kind of one of our newest releases. We're very excited about it. Hope you can make use of it as part of this competition. So Camel Tools is an open source Python toolkit for Arabic NLP. It was created a bit after many of our independent tools we've worked on in the past, and we're trying kind of more and more to move everything that we're doing in the lab into the space. And by making it an open source, if people are interested in providing additional components into it or helping us improve it, we're very, very happy to do that. So the focus of this toolkit is on Arabic. We want it to be as flexible and reusable as possible, highly modular. Done in Python, of course, makes it quite easy for a lot of people to start. And we would say high performance. We're not necessarily always committing to saying that we are doing SOTA, because that's quite hard to kind of having all of these different targets to reach. But at least for a lot of people, it's quite competitive for certain applications, and it comes with a lot of ease of use that would make it a good space for them, a good utility for them to use. So we'll just keep that in mind as you compare these tools for what you need. This is just a quick comparison compared to some of the other most famous toolkits that also have Arabic in them. So Medimira is a toolkit from Columbia that I was actually involved in the creation of. It's in Java. The Stanford Core NLP is also Java with Python bindings available to it. And then Farasa from the QCRI group in Qatar has also is in Java. And obviously there's lots of these tools have connections through Python. You can access them. There's other tools that I mentioned at the bottom. These are the ones that I'm kind of aware of as being very active projects that are ongoing that also hit as many of these issues, like having a command line interface and an API also, expose pre-processing, morphological modeling, doing the disambiguation that we talked about with the spelling issues, the diacritization if that is of interest, lemmatization, basically to extract the core meaning of the word, named entity recognition to identify, are we talking about specific entities like the president Trump or blah blah blah, right? Sentiment analysis, the area you're interested in. So there's actually a utility for sentiment analysis. It may end up being your baseline to compare with, and of course dialect ID, which helps you identify which dialect you're working with. This is on GitHub, right? The link is here if you can find it. And we have very detailed documentation. I'm aware of the time. I'm just pointing the link. I'm just going to go through the rest of the talk of just showing you examples of using it. So at least we have a few minutes for questions if possible. But yeah, it's as simple as doing a pip install on Camel tools, and then you are ready to go. And the different modules that we have, here's a listing of them. I'm actually going to go through them one by one, so I'll spare you this, and we'll just jump directly into them. So some of and these are even examples of code so that you can get started if you want, as fast as you want. So very basic utilities. Some of this stuff is very basic, but it's extremely important that I'm going to start with. So things like normalizing Unicode. So for instance, this particular example is of one single character that is a complete sentence in Arabic that, if you use the Unicode normalization, this allows you to basically go from that form to something that is easier to use with the remainder of the tools. Orthographic normalization, I hinted at this, these different forms of the alif, I call them the alif hamzas, where basically very slight variations are actually elided. So if you look at the example at the bottom here, for instance, you'll see that, here and here, the spelling has changed on these positions, because these are actually common places where people make spelling errors and spelling inconsistency. So normalizing these different forms is something that is also a standard toolkit. So instead of you going and writing the regex specifically for it and looking up, you have the utility for it. You can just go ahead and use it. Simple, again, very basic pre-processing stuff like removing diacritization. You can see the difference between the input and the output with all of the diacritical marks removed. Splitting Arabic, if you want to do basic tokenization that is also aware of the uniqueness of the Arabic characters, like for example, the right to left question mark in this case at the end of this example. Transliteration. This is actually an interesting little thing that people are not completely consistent on using. It used to be more popular in the past. And it's about mapping from the Arabic script to a romanization. In this example, we mapped the sentence, the ذهبت إلى المكتبة, into this star HBT, larger than LY, al-maktab P. This is a letter-to-letter mapping. It's one-to-one. And for people who are not necessarily comfortable with reading Arabic or are really bothered by the issue of the display support not being consistent for Arabic, this makes a very nice utility. You can just do all your work in this Romanized space and then talk about the words that you're interested in or look them up, because you can map in a very, it's a very strict direct mapping one-to-one. So something also to consider as a utility that can help you. Now we get to the more heavy business stuff like morphological analysis. So when you get a word, give me the detailed analysis of this word. I did say Arabic is rich morphologically, so this is kind of what that translates into effectively, the kind of details that you get back. So in this particular example, we have to actually use a morphological database. This is why we import the MorphDB, and then we actually need the analyzer, because there's actually different modules that are used for doing analysis or generation. Generation is the opposite, kind of, where you say, I'm thinking of a word and I want it to be, masculine and singular, and I want it to give it the definite article. What would it look like, when you actually, generate it? This may not be as relevant for the stack, but I can imagine interesting ways of kind of linking different resources to each other. Now, the analysis given a word would give you kind of a detailed analysis of all the features of that word. So in this particular example, and this is not everything, actually, this I think is almost half of the number of the features that you get. So you get the diacritization, of the word, you get its core meaning, the lemma. This happens to be the verb, and they will write it. So this says the verb to write, the root, which is a kind of a concept in Semitic morphology that's important here, pattern, which is the style of when you get the root and the pattern together, you generate the word. How do you pronounce it? The gloss in English. This could be useful, by the way, for people who are interested in using additional resources in English, let's say. I mean, same with anybody who wants to say, there's been research, in fact, on doing sentiment analysis through translation and then analyze the sentiment in the target language and reflect it back. Part of speech, different types of part of speech. There's actually multiple different approaches to define part of speech in Arabic that are developed by different groups. This is only some of them. And then different features like the gender, the number, the person, different tokenizations that you can use. This particular set of features here is actually very useful, and we have a special interface for it. Remember the example I used at the beginning where I talked about chopping up the word in a particular way? we have lots of ways of chopping up the words. And it turns out for certain tasks, at least in my experience with machine translation, you have to kind of try different settings to see what would actually work optimally for the particular task that you're interested in. So think of these as basically things that are available to you that you can use in potentially different ways to help you. Plus basic probability that are out of context, right? Just, what is the likelihood of this llama? What is the likelihood of this part of speech? That kind of stuff. All right. Generation, I mentioned briefly, that's the opposite of the analysis, where you have a llama and then you tell me, I want this to be treated as a noun that is masculine and plural. What does the plural look like? And then you get basically output for these. Reinflection is slightly different, where you start with a word, you don't know what the word is, you don't know what the lemma is, that you just say, can you make sure that it has these features? Now, these kind of techniques may be interesting for people interested in the competition here from the point of view of creating synthetic data, possibly, because you're generating alternative forms of some things. I don't know. It's something that could be actually considered as something that could add an extra dimension of research. Morphological disambiguation, or the way we treat disambiguation, as basically a form of saying, well, this word has lots of analyses. I'm going to tell you which analysis is the right analysis in context, right? And that's basically how we think of the disambiguation problem. That first we analyze all the different possibilities, and then we decide among them which one is the right one. So when you check out the paper on Camel tools, it actually mentions having a very simple and fast maximum likelihood disambiguator. That's the one I'm exemplifying here. That's actually quite fast relative to the other one that is a neural-based one. The neural one is actually not currently officially part of the toolkit. It sits separately as a separate repo, and the plan is to integrate it in the longer term. If you're curious about it, let us know. We're happy to connect you with it. And then tagging is about specifically looking for certain features like the part of speech tag. Now, this could be also useful, right, as a specific feature that you can add into whatever machine learning components that you're using for the tweets, etc., that you have. And it's, again, not even, 5-6 lines of code, and you're ready to have your Arabic part of speech tag sequence that you can use. Tokenization, I mentioned it earlier in the context of the disambiguation. And in fact, we need a disambiguation system with a tokenizer module to interface. And then you can then specify the scheme, because there are different schemas, some of the examples that I showed earlier, but also have different ways of actually saying, generated split, generated it diacritized. I want it to be not split but marked as, same number of words, but the marking is within the word. For instance, this word here is the first word in this 2-word sentence, and it can be tokenized as a single sequence with an underscore separating the two parts, or as 2 separate tokens that you can use, right? And here, just for the Arabic speakers who may be alerted that some things may actually look a bit weird appearing in different positions, this is actually the diacritical mark, and things are appearing slightly in the reverse order, but that's just because of the display is not as good. So just keep that in mind also. Don't get stressed when you see things like this. Almost near the end here, so dialect identification. Again, very simple interface where you import a dialect identifier from Camel tools. We have already pre-trained models for the dialect identifiers, and then you give it a bunch of sentences, and then you can look at the output in terms of the city and the country and the region that you have. So here we have 2 sentences. The first one is actually Moroccan Arabic, and the second one is in Lebanese Arabic. So that's how you get the city Rabat versus Beirut, or Morocco versus Lebanon for the country, or Maghreb versus Levant, right? So you get the regional level, the country level, and the city level. And again, different features that may actually be useful as you are actually optimizing your learning for your task. And then sentiment analysis. Well, this is the main dish of what you guys are trying to do. So I offer basically an alternative here that you can use. Also, you can use it as part of a a set of features that is in addition to what you're doing, of course, right? You can use, kind of think of it as an ensemble technique of some sort. The sentiment analysis, the dialect ID, and also the named entity recognition, which is the last one I talk about, we all use BERT models, actually, using ArabBERT is our recommended utility, which is, I'm not sure actually if Wasim, who's going to talk after me, will be talking about that. But this is what we actually use as part of developing these tools. So we do fine tuning with ArabBERT on them. The last one is named entities, where given some text, we go over the text and we tell you identify blocks where things are marked for it's a beginning inside the technique. So here, for example, the word that is starting with this word gets B location, meaning it's the beginning of a location, inside of a location, inside of a location. And that tells you that this sequence here is one named entity, which is this one here, Al-Imarat Al-Arabiya Al-Muttahida, or the United Arab Emirates, is basically identified as a named entity. So this could allow you to do in some way, the opposite of tokenization. It's kind of identifying multi-word constructions and just say, you know, I saw these three words, they go together, I'm gonna plug them in together, but I'm gonna kind of chop other things apart to find the right level of representation that you would use for your machine learning. Again, just pointing, the documentation is there, the GitHub is publicly available, and I'm almost out of time. I hope what you got from this is a sense about the field of natural language processing, large and growing fields, very exciting, has had a lot of improvement, but there's a lot of new problems that are generated, and we're always looking out for things to do and that are interesting. Arabic particularly has a lot of complexities. I hope you walk away from this not scared and worried, but rather kind of encouraged by the challenge. It's a beautiful language. If you have the chance to learn how to read it and learn about it, I would, of course, I'm biased, I would encourage you to do that. And now we have a lot of utilities, and I pointed out to our tools, but other tools that are available that you can use, and consider being a good member of the community and give us feedback and support. And let's keep this energy and work happening. Finally, I'm very thankful to Kaus and WTI and these for this competition, because I think it's really important to get more people interested in this area and for developing better understanding and better solutions for it. And I thank you very much, and I hope I did not go over my time. I think we have a couple of minutes possibly for questions. Thank you.
Oh, thank you so much, Professor Habash, for your very nice talk. Let's see if we have some questions from the audience. So actually, I see some question about where they can find the slide, or where they can have the recording, and they want to review this after our event. So
sorry, I do see some questions. I can perhaps answer them quickly if you want.
Okay, sure.
Yeah, so the first one actually says in Arabic language. I'm happy to provide a version of this in Arabic in the future. I've done it, in fact, in the past, but today I think it was a much wider audience. Can we access Camel website tools and resources from off campus? Yes, you can. This should be all public. The GitHub link is public. I will share my slides with Chen Yang so that she can make them available to everybody. So all the links are there. If you have trouble accessing them, please let me know. That would be, I'm happy to help with that. The data sets are free for research purposes. Some data sets, some models are free because they're models, but the original data is not free because it's not our data. So we cannot give something that we do not own ourselves, but everything that we've annotated ourselves, we've made public and free. Check these out. If something is unclear, email us. Our information is public. We're happy to answer. Criteria for high quality annotation. Oh, that's a really big, long conversation. Amani, I think, asked this question. It depends on the task that you're doing, but there are certain metrics that are used, like inter-annotated agreement, where you ask, can two humans learning the set of guidelines, do the same kind of annotation with a high degree of agreement. And there's a lot of different techniques for measuring agreement, but this is typically what we do. Say, if two people can agree on it, it means that there is a potentiality that we can actually get a machine to learn. If two people cannot agree on it, like if you say 50% of the labels are in disagreement, why would you expect somebody else or a machine to actually learn anything? GitHub links will be shared. Thank you for all the positive comments. I cannot answer things about certificate of attendance. That's not for me. And yeah, do you need to change your data sets to use one of the NLP models? It depends. If you are using the model that we have, our interface make very, very minimal assumptions. It's just text. If you have the text, so it's very minimal. So that would be kind of on you to figure out, how to extract just the text version so you can use it. But if you want to retrain, some of our stuff can be retrained. Some of it is not, the code for it is not public yet to retrain. Our goal is to make everything that we're doing public and available even for the training, so you can actually get your own dialectal data and train them. But it's, as you recognize, even though as we have this large group of people who are involved, or we're involved, some of them are actually have left us, but they were all members of the team, we have to prioritize. But if you email us, ask us, this will encourage us more to make it a higher priority. And just, the best way to actually contact us with issues and questions is to go through the GitHub interface and put an issue through GitHub, better than emailing me directly about things like this, if it has to do with Camel tools. Okay, and I think I'm crossing into Asim's time, so I should stop at this point.
Thank you so much. I see there are many questions, and I will try to answer some of them by typing. And thank you so much, Professor Habash.
No problem. And Shenyang, I mean, if you have questions that you would like me to answer, just email them to me, and I'm happy to email them. I'm not sure what is the form of answering them in the longer run, but I can be aware for the future at least.
Thank you so much. Thank you.